Hello good people, I'm going to talk about logarithms. Logarithmic notation or logs allow for the calculation of a power that a base needs to be raised to in order to give a certain value. To unpack this statement, we need to revise powers, bases, and radicals. Remember those? Don't worry, they remember you. Suppose that we have this problem. We want to calculate the value of a base 7 when raised to the power of 3. According to my calculator, 7 raised to the power of 3 is 343. Fair enough, but let's play with this expression. Suppose that the problem was framed a little bit differently. In this case, we are told that there is an unknown base that needs to be raised to the third power, and we are hoping to obtain a value of 343. How do I solve for b? Well, I need to transpose this to the power of 3. And recall that if we want to transpose powers, we need to use radicals. To transpose a third power, I needed to employ a third radical. According to my calculator, the third radical of the value 343 is 7. In these two first examples, we had a situation where the value was unknown and we solved for it, and then we had a situation where the base was the unknown and we solved for it as well. However, the power can be an unknown as well. In this third scenario, we are saying that the base is 7, it's going to be raised to some unknown power p, and when everything is said and done, we are hoping to obtain a value of 343. What is the power? Well, based on the two previous examples, we already know that the power is meant to be 3. But what if we didn't know? How would we calculate it? This is where logarithms come into play. The unknown power is equal to log to base 7 of the value 343. How do we enter this into our calculator? Well, we do have the log button, so I'm going to press that. I need to enter the base. Maybe that goes into the bracket. So here we go, base of 7, I'm going to close the bracket, and then I'm going to enter the value and press the equal button, and the calculator is telling me that I've broken mathematics. So that is not it. We need to keep in mind that this log button is programmed to be log to base 10. How do we solve when the base is not 10? Well, luckily, we can perform what is known as a log 10 base conversion. This logarithmic expression can be rewritten, and we are going to have a scary looking fraction, but luckily, the calculator will do the number crunching for us. Above the line, we will have log to base 10 of the given value, in our case 343. And that will be divided by log to base 10 of the given base, in this case 7. I'm going to use fractional notation. I'm going to enter log. The calculator knows it is log 10, so I'm going to enter the value in the bracket. Then I'm going to go below the line, enter log again, and enter the given base. Once everything has been entered into the calculator, I'm going to press the equal button. And now I can say that the power equals 3. In order to calculate a value, we used power notation. In order to calculate a base, we used radical notation. And in order to calculate the power, we used the logarithmic notation. These three notations are linked, and we need to be comfortable with changing from one to the other. With that in mind, let's try a few exercises. Here are three expressions. The first one is written using power notation, the second one using radical notation, and the third one using logarithmic notation. I invite you to pause the video and write each of these expressions in the two notations not yet shown. Already finished? Fantastic. I still insist that you watch me do it, if only to make sure that I'm doing it right. The first expression is 16 equals 2 to the power of 4. What does that look like in radical notation? Remember, in radical notation, we are solving for the base. The base stands on one side of the equation alone. And in this case, the base is 2. And it has to equal the radical power, in this case 4, so the fourth radical, of the given value 16. There we go. We have written it in radical notation. What about the logarithmic notation? The logarithmic notation solves for the power. In this case, the power is 4, and it would equal log to base 2, because that was the base given to us, of the value 16. What about the second expression? It has been given to us in radical notation. I am firstly going to rewrite it using power notation. So this time the value 243 stands on its own, and it is equal to the base 3 raised to the power of 5. In case of logarithmic notation, we are solving for the power. The power is 5, and it would equal log to base 3 of the value 243. In case of the third expression, it has been given to us in logarithmic notation. I'm going to rewrite it using power notation. The value is 4096, and it is equal to the base 4 raised to the power of 8. In case of radical notation, we are solving for the base, so the base 4 would equal the 8 radical of the value 4096. Once again, the power, radical, and logarithmic notations are linked. They differ in what we are trying to solve. In case of power notation, we are solving for the value. In case of radical notation, we are solving for the base. And in case of logarithmic notation, we are solving for the power. I'm going to invite you to solve 3 more problems. In each case, the first step is to decide what is the unknown, the value, the base, or the power. Deciding that will help you choose the correct notation to actually solve for the unknown. In the first case, we have log to base 7 of a value x gives 5. So, in this case, the value is the unknown, which means I'm going to use power notation. X equals 7, the base, to the power of 5. And if I use my trusty calculator, 7 to the power of 5 is 16,807. In the second problem, we have 512 equals x raised to 9. So in this case, x is the base. That is the unknown, which means I'm going to use the radical notation. X equals the 9th radical of 512. According to my calculator, the 9th radical of 512 is 2. One more to go. So this time we have 4 equals some unknown radical x of value 4096. In this case, x is the power, which means I need to use logarithmic notation. X will equal log to base 4 of the value 4096. Now, seeing how my calculator does not know how to handle log 4, I'm going to perform the log 10 conversion. And once again, I'm going to use my calculator to help me solve this. According to it, the solution is 6. One of the great things about these 3 notations is that one of them can be checked by the other 2. In this last problem, we are saying that if we have a base of 4 and raise it to a power of 6, we should end up with the value 4096. So I'm going to use the calculator to check that. Base of 4 raised to the power of 6, and fantastic, we are receiving 4096 as the solution. These 3 notations live and breathe as one, and these 3 general equations at the bottom of your screen might prove very useful. That is all for now, and I will see you on the flip side.